prestigious international conferences attended by world-class scholars was an effective way to promote Italian research and culture in the international peer communities and to give Italy and fascism a good name in international public opinion. If anyone had any doubts on that score, they had only to note that the opening of the conference on Sunday, October 11th, 1932, was presided over by Il Duce, his prime minister, and his other chief lackeys, all resplendent in fascist finery. Willingly or not, Royal Academy of Italy President Marconi publicly praised Il Duce for his support and his ostensible enthusiasm for theoretical physics. Conference organizer Fermi was certainly no supporter of fascism and would later leave Italy in 1938 when Mussolini followed the example of his fellow dictator Adolf Hitler by enacting anti-Jewish laws. For now, though, he did his best to keep politics out of the conference, assuring participants that the proceedings would remain strictly scientific. Scientists were supposed to be civil, polite, disinterested, above it all. Still, some concessions had to be made, distasteful as they might be. As Pauli later noted, those mostly came at the formal receptions, as he wrote to his friend, "Orribile dictu, I had to shake hands with Mussolini." 1. A very interesting discussion. In the days before routine commercial air travel, intercontinental journeys weren't casual affairs. Distances, whether across the surface of the globe from one point to another, or from the ground up into the reaches of the sky that would later become inconsequential, were anything but casual in the early 20th century. If you were traveling from the United States to Europe, for example, you first had to get to a major port city, such as New York or Boston, which, unless you were fortunate enough to live in or near, meant a train trip of several days to a week. Then there was the transatlantic voyage, which took 1 or 2 weeks, ending at another major port city, such as London, and then further travel from there to one's ultimate destination, again usually by train. If you were an eminent American academic and scientist, that meant putting your lab work and teaching on hold, or leaving it in the hopefully capable hands of your graduate students, and clearing your schedule, probably for at least a month. So one didn't do such things lightly. You wanted to have a good reason for such an investment of time and energy, not to mention money, even though your university would probably pay for the trip, at least if you were a big shot. In the United States of the 1920s, Robert Andrews Millikan was definitely a big shot. It would be enough that he was the second American physicist to win the Nobel Prize, but he had also helped to establish the California Institute of Technology, Caltech, which was steadily becoming a friendly rival of long-established centers of scientific learning such as the Massachusetts Institute of Technology, Harvard University, and the University of Chicago. To Millikan, taking long and exhausting global journeys all came with the territory of being America's most celebrated and eminent scientist. His 1923 Nobel Prize in Physics had come mainly for measuring the charge of the electron, a nagging problem in physics that especially appealed to his passion for exactitude, precise measurement, and hands-on experimentation. It also provided a long-awaited confirmation of his scientific self-worth at last. Until he began the electron work at age 41, he'd been leading a respectable but relatively unexciting career, noted mostly as a professor who'd written some successful physics textbooks. After his Nobel triumph, Millikan turned his talents to the study of the mysterious ambient radiation that scientists had begun to detect in the atmosphere. By 1925, Millikan proved that these mystery rays were coming not from the atmosphere or the ground, but from outer space, and dubbed them cosmic rays. Further work by Millikan and others confirmed their extraterrestrial origin. But as is usually the case with science, solving one mystery merely revealed a completely new one. What exactly were these cosmic rays? Specifically, were they charged particles like the electron, or neutral packets of energy such as photons of light? Millikan decided the latter, and given his status and obvious expertise, few were inclined to contest him.